In this video, we're going to learn how to go from the name of an ionic compound to the formula of an ionic compound. So we're going to look at calcium phosphide as our first example. Our first step is to write the ions with their charges. So we're going to go ahead and write the symbol for calcium, which is Ca. And then we know that's an alkaline earth metal, so it's got a +2 charge. And then we're going to write phosphorus. Phosphide is actually phosphorus, and that has a -3. Something to note is that if it's a transition metal, the chart will be in Roman numerals. If it's a polyatomic ion, the chart will be on the back of the table, periodic table. And we know the polyatomic ions are typically going to have an ATE or ITE ending. There are a couple of exceptions like hydroxide and cyanide, but for the most part, if you see ATE or ITE, you know that's on the back of the periodic table. Our next step is to determine how many of each ion is needed to make that a neutral compound. So we have Ca +2 and P -3. We talked about anytime you have that 2-3 split, you're going to go ahead and get them to 6. So we're going to add a -3 charge to have -6. We're going to add 2 more calciums. That's going to give us a +6 overall charge. Then we're going to go ahead and use subscripts to show how many ions are present. So we have Ca3, P2. Our last step is to use parentheses with the polyatomic ions if there's more than one. We didn't have a polyatomic ion here, so we didn't have to worry about that. So our end compound is Ca3P2. Let's go ahead and do a couple of practice problems. So we have lithium phosphate. We know that lithium's a +1, and phosphate, that ATE, tells us it's on the back of the periodic table, so that's PO4 at a -3. We're going to add 2 more lithiums, so we get an overall +3 charge, -3 from phosphate, so that's going to give us Li3PO4. For this one, we have iron 3 nitrate. Iron is a transition metal. Now this 3 tells us the charge is +3. Nitrate's on the back of the periodic table, so that's NO3 -1. We're going to add 2 more of those nitrates to get the charges to cancel. -3 here, +3 here, and that gives us Fe. And then we have 3 nitrates. Nitrate's a polyatomic, so we're going to put that in parentheses. Don't forget that NO3 is that whole polyatomic, and then the subscript 3 goes out here. We've got 2 more sets of practice problems. So this next one is titanium 4 oxide. So titanium is Ti. This is the charge on titanium because it is not an alkali, alkaline earth, or aluminum, zinc, or silver. This is 4. Oxygen's a -2. We're going to go ahead and add another oxygen to balance out our charges, and we get TiO2. And then finally, we have barium phosphate. Barium is Ba. It is an alkaline earth, so it's got a +2 charge. And then phosphate is on the back of the periodic table. That's PO4 at a -3. We have that 2-3 split, so we're going to get to 6. So we've got our +6, -6, and that's going to be Ba3. And then I have more than one polyatomic, so that whole polyatomic ion has to get in parentheses, and I have 2 of those. If you had any questions, go ahead and write it down, and then the next time we see each other, we can go ahead and go through them.